Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of slope-intercept form, specifically how we can represent problem situations with equations, tables, and graphs, and we'll do it in 5 minutes or less. So we have a problem situation here with a teacher going back to school shopping to buy supplies. She's buying packs of hand sanitizer for $2.50 each. We have a coupon here for $1.50 off the entire order. So we need to represent this relationship here. So X is going to be the number of hand sanitizer packets. So I'm going to put that X right there. And then Y is going to be the total cost. So we know our slope-intercept form here is going to look like this. Y equals mx plus b. And if we label this here, we know what the X and the Y are, right? So this m is going to be our slope. And then this b is going to be our y-intercept. That's very helpful when we are graphing. So that's what those two things are. And so let's see if we can figure out how we can first write this as an equation. So we know y is the total cost. So that makes sense. We want to solve for the total cost here. Now, the slope is also going to be our coefficient right here. And so what are we multiplying this x by? So x is the number of hand sanitizer packs, and each hand sanitizer pack costs $2.50. So one would cost $2.50, two would cost $5, and so on. So we're actually going to multiply the number of hand sanitizer packs by the cost. $2.50 each. I'm going to drop the $sign and the 0. I'm going to make it just 2.5x. That's how we represent money right there. And then we need to find the y-intercept. So if we've got an x of 0, how much would that y-intercept be? And so that's going to be our constant here. And it's a coupon for $1.50 off. So notice it's $1.50 off. So we're actually going to, normally we add, well, we're just going to subtract here. We're going to subtract 1.5. That's going to stand for my 150. So that's how we would represent this as an equation. Let's see if it makes sense inside a table. So let's do a little x, y here. Now the 0 doesn't quite work. It's not going to necessarily start, right there at our origin, because then that would look like it's going to have a 0, negative 1.5. So that's going to be kind of a strange graph. So let's start with 1 right here. So if we buy 1, then we are going to have 250 minus 150. So that's going to be a $1. That's pretty good. And if we get 2 right here, right, then that's going to be $5 minus 150. So we're going to have 350. And if we get 3, that's going to be 750 minus 150. That's going to be 6. And we can get one more. We can get 4. 4 is going to be $10 minus 150. And so that's going to be $8.50 or 8.5. So that's going to be our table. How do we represent this as a graph? So let's just draw a graph here. And as you can see, it's going to be a little bit strange here. I'm going to draw mostly in that first quadrant. And it looks like the scale looks pretty similar to both. So I'm just going to use the same scale factor of 1 here. See how far up I got. 1, 2, 3, 4, 5, 6, 7. That's going to be close enough. 1, 2, 3, 4, 5, 6. Let's make that 7. And so let's start graphing this. We'll see how that 0 becomes a little bit weird. But we can go ahead and graph it anyways if we really wanted to. So we've got our 1, 1 right here. And we've got our 2, 3.5. You notice how steep that slope is right there. Then we've got our 3, 6. And as you can tell, we're going to actually go off the vertical end of our graph there. But take a look at this line right here. If we wanted to actually take a look at this, we could graph it. And it's actually going to end up right there if we follow that. We can actually graph that y-intercept there, and that's going to be 0, negative 1.5, but that's how we would graph it as well.